In this session, we'll test whether higher levels of institutional ownership increase management effectiveness. In the background, the finance and economics of this would say, yes, we would expect that because institutional owners tend to be more active in their oversight of management that relative to non-institutional investors, then we should see that this increased oversight increases management effectiveness. So we're gonna test this. Now, this is a common question that I would get from my boss when I worked as a financial analyst. It could be similar questions could be in the form of does delinquency rate on loans increase if the credit score goes down? So there's a lot of as working as a financial analyst, you get a lot of questions like this. So we're going to go ahead and answer this question, and to do so, we're going to use the Pandas library because the data that we're going to use is from a spreadsheet. So we're going to have this nice tabular data structure like you're used to. So what we're going to do is we're going to use Pandas to get that out of the spreadsheet. We're going to read the data from the spreadsheet into a Pandas data frame. Then we're going to clean the data, make sure everything is correct, and then go ahead and answer this question. Good. So jumping in here, the first thing is I'm going to import the Pandas library, and then we can refer to Pandas with the prefix PD. Right? And then the second step here is to actually pull in the data. So the data is located at this URL. It's a spreadsheet, an Excel spreadsheet located at this URL on the web. So, and if you want, feel free to go. You can paste this into a browser and it'll come up and you can open it up in Excel. But the idea here is working in Pandas, we can pull this automatically without leaving Python. We can automatically pull this into our Python session. Now, note what I have here is before you pull any data like this, you have to take a brief look at it. So I've taken a look at the data, and the data starts on row 8. So we have to skip the first 7 rows when creating the Pandas data frame. So that's why I have skip rows here 7. Here's the URL. So I'm using the Pandas function read Excel from this URL, and I'm saying skip rows is 7. It might be useful to make a brief note here that these functions in Python have a lot of different arguments. So arguments are what you feed into the function. So the URL is an argument. The skip rows equals 7 is an argument. Some arguments are necessary that you feed them in. So we have to have a URL here. If we didn't have a URL, Pandas would throw an error. However, a lot of the arguments have a default value. See, the URL doesn't have a default value, but and this could be read Excel. This doesn't have to be a URL. This could be a file on your computer. So it needs some location of the file, right? However, if we didn't put in skip rows, it would just assume skip rows is 0, and we can see the defaults here. It does this autocomplete for us. So somewhere here we should see skip rows, right? Skip rows right here. It says none, right? So we don't skip any rows. So keep in mind, each of these functions has a lot of different arguments. These are all the possible arguments. However, many of them have defaults. So if you're fine with the defaults, you don't have to change it. So skip footer equals 0. That's fine. We don't want to skip any footer. Sheet name 0, header equals 0. So the idea here is this would be the first sheet, and we do want the first sheet, so I don't have to change this. However, if I wanted the second sheet of the Excel workbook, I would have to actually change this. So one thing to keep in mind is, but now you know IO here, this is the location, doesn't have a default. So if you want the default value, you don't have to do anything here. It's only when within the function arguments, you only have to provide anything that doesn't have a default value, or if you want to change the value from its default. And that's what we have here, and skip rows equals 7. Good. So now that we've imported that data, the first thing to do is always view it, right? So we can just type in the variable name. So we stored this Pandas data frame in the variable name institutional ownership, right? So we can just print it out here, and it prints the nice Pandas data frame, and we can take a look at it. Now what it does by default is just print the first 5 and the last 5 rows. And looking at it, we see we have a column here with no name. No name, and there's no data in it. So first thing we want to do probably is drop this column, right? So we can go ahead and drop that column with this code here. Now, the one thing I want to note about this column, so what this does is institutional ownership, and then we drop the columns, and then we're providing the column name. The column name is unnamed : ;5. So this tells Pandas which column to drop. And then we have this InPlace is true here. So what this does, and we're going to use this throughout, what this does is it tells it to modify this actual data frame. You see, the thing is, if I had InPlace is false, what it's going to do is it's going to drop this, but it's not going to affect the actual variable, right? So I'll show you here. So institutional ownership, and you're going to see this is dropped. That column is dropped. However, if I print institutional, so this here returned a data frame with the column dropped. But now if I print it, you'll see the column's still there, right? Because it didn't actually affect this data frame. And the reason why I would have this here is if I wanted to create a new variable, inst own2, right? I miskeyed that, but so now I could have my original data frame wouldn't be affected, and I have a new data frame, right? So that's when I would have InPlace is false, and I believe InPlace is false is the default value to the function. InPlace is false. So that would be, if you didn't have the InPlace, that's what it would do. So keep in mind, if you just have this here, right? Now again, you would have to redefine it as a new variable because it will not affect the original data frame. However, I don't want to define a new variable. I actually want to just affect this data frame. In that case, what we do is the InPlace is true. Good. So now this inst-own data frame will be affected, and I print it out, and the column is gone. Excellent. So now in Colab we have this, so it nicely shows that this is 96 rows and 5 columns, but the Pandas data frames will have an attribute which will show me that data. So I can print this and it'll show me, so this is the shape attribute of the Pandas data frame. Inst-own is a Pandas data frame, and this is the shape attribute of that data frame. It shows me 96 rows and 5 columns. Now, what is very important is to look at the type, the object of the type of each column. So the idea here is when Pandas imports an Excel spreadsheet, it tries to say, okay, well that looks like a string and that looks like a number, right? And what you want to do is make sure that it gets the strings and the numbers right, because sometimes there could be some bad data in one part of a column, and instead of importing the column as a number, it'll import it as a string. And as we know, the plus, if we add 2 strings together, it behaves differently than if we add 2 numbers together. So it's really important to know the type of each column. And we can do this with just looking at the D types here. And what we can see is industry name. This is a string in Pandas. Number of firms is an integer. That makes sense. We don't have a fractional number of firms, so that makes perfect sense. And then we have floats. So these are floating point numbers. These are numbers with decimal places. And this all looks good, right? So in other words, our data was imported properly. And again, this is important later because if let's say both of these were imported as strings and then I try to add the 2 columns, it's going to just concatenate them. So, but now we know if I add these 2 columns, it will add the numbers. So, what I've done here is to show you what an error might look like and how you would catch it. So what I did is I uploaded this same spreadsheet to my GitHub here and put an error. So what I did is I inserted a character at a random point, right, in the spreadsheet. So if we read this, we can read this in. So this is the data frame with an error. Drop the column, and then we look at the types of each column. And what we see here is in institutional holdings, now this is a string. So we know institutional holdings should be, right? We can look at it and say institutional holdings should be a number, right? We can actually look at it here, right? Right, and we look at it, and we should know it. It looks like it should be a number, but yet it's not a number. So there must be an error, particularly in these rows that we're not seeing. So what we can do is we can take a look at all of these. We'll just take a look at them. Now, one thing is note that there's a setting here that says only display first and last 5. So we can change that setting to say display 1,000 rows. There's only 96 rows here, so that's fine. We could just have 100 here. But I'm just saying basically show every row. And then we can choose just the institutional holdings column by via this, right? So we have the brackets quote column. So this will return only that column, the institutional holdings column of this data frame. So when we run that, it prints out all the column. And what we can do is right here, we can kind of visually inspect. I'm going to bring it up to the top. And right there, it jumps out, right? So here, there was a G, right? 5G3, so it read string, right? But all of these have to be of the same type. So once it realized this is a string, it made everything a string, right? So it's one thing to keep in mind in a Pandas data frame, the columns are all of the same type. So and a string is a more sort of general type than a number. So when it couldn't make everything a number, it just said, okay, I'll make everything a string. And so that's what we have here. So this is at row 25. We need some way to fix row 25. So what we can do, 2 approaches, and this will be dictated by the data and your knowledge of the data. We can either, if we're confident, we could just remove the G and make this 0.53926, or if we're not confident about the data, then we probably just want to drop it, just get rid of this row. So first, the maybe slightly safer thing to do, if we know this is there's an error in that row, is to just drop the row. So we can do that first, right, and say institutional ownership with error. This is our data frame, and we'll use that drop function again. And this axis is going to say, well, so what we have is index 25. So this is saying drop the 25th row, right? Now, I have an InPlace is true here. So right now, InPlace is set to being false. So let's actually, we want to do that. InPlace is true, right? So we can run that there. Now, if we do this, right, we should still get, so let me now print out inst ownership with error. So now, and we'll put up D types. Now, what we still should see is that everything's a string, right? It shouldn't have changed the type. So we still have institutional holding string. So what we did was we dropped a row, but Pandas didn't automatically update the type of the column, right? We can confirm that what we want, let's say institutional holdings, we can confirm that what we want is gone, right? This was row 25 previously, right? So what we want is gone. And we actually can update the index here, but we won't worry about that right now. What we want is gone. However, it didn't update the type. So what we want to do, and actually I didn't, and that's why I had the InPlace is false. So so let me do that. So what we'd have to do here is rechange the types. So we'll set the type, and I will do that after I simply use the other approach of changing the data in row 25. So let me re-import this because I have changed it. there we go. So now, and that's why actually I had InPlace's. Note that this comments out the rest of this. So the idea here is now InPlace would be false, so it would not affect this if I ran it. So that the hashtag here is the comment character in Python. So the alternative approach would simply be to change the data in location 25, and we can do this here. This is our data frame. This is the column we want, so this just selects that one column from our data frame, and this says at location 25, set location 25 equal to the number that we want, right? So we should be able to run that, and what I'm doing here, so now that sets the location, this would print it out, but what this does, so this changes the number. We can kind of forget this at this point, and what this does here is it sets this column to numeric. Because again, once I've changed this number, right, I'm going to run this here. Have I run this? Well, if I've run it, yeah, I've run it. So, so it will not be a string type anymore. But if I had just run this thing, the column is still a string. However, this line says this column that we've been working on of institutional ownership with error data frame, set this column to numeric. And then it redefines that column here. So it says, basically, in this data frame, change this column of the data frame to numeric. And if I run that, I get float, float, float. So to solve our problem here, we have to either drop the row or rename that entry in the row, and then change the type of the column to numeric. Now, once we've done that, we're good, right? This, a little bit here is, again, how to select columns. We've kind of gone over that, but it's just an explicit showing you how to select, one column. Now, what we can do in our data frame is, let's say, well, we're interested in institutional holdings. However, again, going back to the finance and economics of it, insiders, if there's higher levels of institutional ownership, but also higher levels of insiders, that should also increase management effectiveness. So what we can do is we can create a new column. And to create a new column, all we have to do is give it a name. So here's our institutional ownership, and this isn't selecting a column because this column doesn't exist. It's just, this will create the column. And then we set this equal to these two columns, the sum of these two columns, right? So we can go ahead and run that, and we get II holdings, which is the sum of these two. Right? So we can create new columns easily. And once we've done that, we have an interesting data frame. We might want to get to know it a little bit. So we can sort the data frame and see, let's say, which industries have the highest or which industries have the lowest levels of institutional ownership. So sorting the data frame, we can see that reinsurance, paper, and utility have the highest levels of institutional ownership. And of course, just going back to your typical financial analyst task, you always want to take a look at the data to get to know it a little bit, and this is useful. We can also see the lowest. There's a lot of, and this goes to sort of programming in general. There's a lot of different ways if we wanted to see the lowest. I could just take the tail of this, right? So we see the tail, so the lowest is going to be on the bottom. The lowest is precious metals, metals and mining, real estate. Of course, I could keep this as head, and then I could say ascending is true. It'll just affect, sort of the ordering. Now we have the lowest on top, precious metals, metals and mining, and it's descending down. So there's, quite a few ways to see what we want, but that, that allows us to see the highest and lowest levels of institutional ownership. I'll reset that. So now it goes to our exercise. So now we want to start answering the question of, is this variable, institutional holdings, correlated with ROE? That's going to be our measure of management effectiveness. Now, ROE is in a different spreadsheet. So what we can do here is this spreadsheet is in this at this URL, and we want to skip the first, the data starts at row 8 again, so we have to skip them. So we can read that into a data frame that we're going to call returns. And what we see here is we have ROE, and again by industry name. So both of our spreadsheets have industry name, and that's what we're going to match these two spreadsheets on. And so we want to merge these two so that we can get this into one data frame to calculate a correlation coefficient on institutional holdings and ROE. So let's go ahead and merge the two data sets. So what we're going to do is we're going to use a function in Pandas called merge, and it's going to merge institutional ownership and returns, right? And it's going to merge them on industry name. Now, I don't want to go too far into this here, but there's other ways that you could write this merge. So you could see something like institutional ownership dot merge with returns. There's other ways to write this. That's not, so if you see different ways, don't be worried. I could write this in a couple different ways. But we're going to merge this into a data frame called all data. So we can run this, and we don't get an error. And this is interesting because they must have just updated this these data sets and fixed the error that was in there. Yes, they did. Okay. Well, so what happened before? If you go back to, the last time I ran this, there was an actual error, and what I might have to do is go back and I can recreate the error because it was pretty useful. But right here, I'll just describe the error, and maybe in a separate brief video, I'll recreate the error for you. But the interesting thing was, it threw an error, and the error was key error, right? And I wanted you to see that because, one, it's quite normal to get errors, and then you become more comfortable with just reading what the error is, because Python really does a good job of saying what exactly the error is. And what had happened was in one of these, I forget at which point, there was 2 spaces between industry name. And if there are, so this one, let's say, had 1 space and this one had 2 spaces. And if one has 1 space and one has 2 spaces between industry name, they're different strings. So the key error says, I don't see this in both data frames. So the answer to that was to go in and just, I guess in returns, it had 2 spaces. So this would rename the column industry name with 2 spaces to industry name with 1 space. InPlace is true. And it would have both data frames would have industry name with 1 space, the same string, and then we could properly do a merge on them. So, however, that's been fixed, right? So obviously they found the error. Good, but in retrospect, like I say, if you ever do get an error, no problem. You just kind of read the error, and it will put you it'll show you, it'll put you into the right area to search for and fix the error. And usually, like I said, when I did this, I returned that error, and it took about 30 seconds to figure out what it was, put in this fix. So, and that's constantly happening. So the one thing is, I don't want you to ever get worried if you see an error. You can usually fix them pretty quickly. So now we have the merged data frame, all data. We have industry name here. We have institutional holdings. We have ROE. And now we can start to answer the question. Now, one thing that, to answer the question, I guess I don't have it here, but Pandas does have some visualization and some, it does have some statistical routines. So you can find a correlation coefficient, so you can calculate a correlation coefficient of a data frame in Pandas. So use the correlation. So now, before I go, and so to answer this question, that's what you're going to want to use. You can use the calculated correlation matrix using Pandas, the correlation function in Pandas. Now, there's 1 or 2 things I want to say here before I go. One, note that you would say, well, I can download the data in Excel here and download the data and merge it in Excel and calculate the correlation matrix, right? So does this really save you time? The nice thing about setting this up is that once I set this up once, and assuming they don't change this, now what I could do is I could comment out where I'm renaming this. But assuming the data doesn't change its structure, as they update the data, I can simply go ahead and say file, well no, it's runtime, run all. So I never have to do any of this again. So the data here with ROE and with institutional ownership is updated regularly. So let's say it's updated again, right? Because as we see that when they updated it, they fixed the column name. As it's updated, I can just simply say run all and I have my new correlation coefficient, right? Updated again, I just say run all and have my new correlation coefficient. I never actually have to go out, download the data and do everything. So the real nice thing about doing this analysis in Python relative to Excel is that once I've done it, I never have to do it again. Good. So now, so for your exercise, well, actually it says select only the columns you want, because when you use Pandas, it'll actually create a correlation matrix. Look at the correlation between institutional ownership and ROE. So I'll get you started a little bit here. So if we want to set only the columns we want, right, we can say all data, right, and then we can just create a list and say, okay, well, give me, what do we want? We want institutional holdings and ROE, right? So it has to be quoted, obviously. INST, and ROE. So let's see here, and of course I misspell this, INSTITUT, institutional holdings. All right, so now we have, I just fed it a list, right? So I'm saying just return these, the outer brackets say return these columns, and this just gives them a list of the two columns, right? So now I can calculate the correlation using Pandas correlation coefficient. One thing here, keep in mind, if you ever want to, while you're going through this, you might also, and I think I have a link to it somewhere here, but Pandas has great documentation. So I have here Pandas merge. If you ever want to see, what are the arguments to merge, this Colab will show you these, but it's also very useful to see this documentation, right? And if you want to say, okay, well, if you want to look at, you might not know that the function is named core, but if you want to look at the correlation coefficient, you can just type in correlation. I want a correlation matrix, right? And it'll give you a copy. So in other words, I want you to be able to do this yourself, and I want to show you, where to go to get the data. Good, excellent.